Hello, my name is Doyeon Ahn. I'm a postdoc scientist at George Washington University. My research project is focused on CO2 emissions from global C40 cities, and I'm going to talk about self-reported emissions inventory, gridded emissions products, and satellite observations. C40 Cities Climate Leadership Group has a total of 96 C40 member cities as of now, which represent 20% of the global GDP or 582 million residents globally. 61 C40 cities already have 1.5 degrees Celsius goal-aligned climate action plans as of 2021, and 24 cities have pledged to divest from fossil fuels. These climate action plans not only mitigates greenhouse gas emissions, but also expect to have co-benefit of improving air quality. For example, in 2021, 32 million global city residents experienced improved air quality compared to 2020 based on satellite data. As of February of 2022, 80 C40 cities have submitted their own greenhouse gas emissions inventory. In the map here, I'm showing the CO2 emissions from a total of 76 C40 member cities, according to their own self-reported emissions inventory. Another component of my research project is global scale gridded CO2 emissions products. These products attempts to downscale national and annual CO2 emission estimates using various kind of spatial temporal metrics, such as nightlight imagery, population, traffic pattern, and power plants location, etc. I'm using 3 different global emissions products, such as EDGAR, FFS, and ODIAC, and I'm showing how these models are showing the spatial gradient of CO2 emissions along Washington, D.C. and Boston corridor. I compare CO2 emissions from C40 cities according to the gridded emissions products versus their own self-reported emissions inventory. We find that emission estimates from these 3 gridded products show good correlation compared to the self-reported emissions inventory. And we also find that emission estimates from these 3 gridded products tends to be larger than the emission estimates from the self-reported emissions inventory. And such discrepancy is largely driven by the cities that are belonging to Group B, which is including the region of Africa, Asia, Latin America, and Oceania. Lastly, an ensemble of 3 gridded products showed improved agreement toward the self-reported inventory. The last component of my research project is analyzing satellite observations. OCO3 satellite, which was launched in 2019, has an observation mode called Snapshot Area Maps, or SAMS. This mode collects the data over 80 by 80 kilometer in 2 minutes, and it currently has 235 fossil target sites, which include 63 C40 cities located in 30 different countries. On the map here, I'm showing Washington, D.C. on March 3rd of 2021. On the left side, I'm showing the column CO2 data observed by OCO3 SAMS mode. And on the right side, I'm showing the column and a tour from Chart-Bomi satellite. So the big objective of analyzing these satellite observations is to assess the co-benefits of urban climate action plans on greenhouse gas mitigation and also on improvement in air quality. We are currently working on separating column CO2 enhancement signal due to urban anthropogenic CO2 emission sources from the OCO3 SAMS mode observation data. And then we are going to estimate the emissions of urban CO2 and NOx emissions, or the trends of the emissions, for 63 C40 member cities. Also, we are planning to analyze NOx to CO2 ratio for C40 cities using the Chart-Bomi and OCO3 data so that we can better understand the source sector composition of different cities globally. Thanks for listening. If you have any questions, please send me an email. And also, I'm looking forward to have an in-person conversation at Houston. Thank you.